Welcome to my channel. Today, in this session, let us discuss the transient and the transmission line. Already, we have discussed the transient and the case of the asynchronous machine, asynchronous generator. And here, there we have discussed about what they mean by the transient, subtransient reactance, transient reactance, and etc. Here, we are going to analyze the transient and the transmission line by considering a single phase. If we consider a single phase, the transient will be in such a manner. For the voltage equation, it is given by the root 2p sine omega t plus alpha, and we are going to consider it consists of a passive element such as resistance and the inductance. From the circuit diagram, the current after the short circuit is composed into the two parts, right? So the current is given by Is is equal to Is plus It. This is the steady state current plus the transient state current. We are going to analyze the transient state. So the current we are going to classify into two cases after the short circuit. Okay. So if the short circuit takes place in the any kind of the transmission line, the short current in the transmission line is as I is equal to Is plus It, right? Is is given by the formula root 2b sine omega t plus alpha minus theta divided by its impedance, right? For is impedance Z is given by root r square plus omega square L square. This is the root, square root of R square. So this is given by the formula of series RLC circuit, right? And angle theta is equal to tan inverse of omega L by R. This is in case of series RLC circuit, angle theta will be equal to tan inverse of omega L by R. And the transient current IT is given by the formula root 2 B by modulus of Z. That means the modulus of impedance sine theta minus alpha e power R by L. Since the transient we are providing a decaying part, E is equal to root minus R by L T. The short circuit current of these two is given by the addition of Is plus It, and the short circuit current of the transmission is given by I is equal to root B by impedance sine omega t plus alpha minus theta plus root 2b by impedance sine theta minus alpha e power minus R by L T. This is the current equation for the transient transmission line. The transient current equation for a transmission line. It is analyzed by a means of a single phase transmission line. We well know that the transmission line consists of a passive parameters RLC. If any case of fault happens, there will be an or an L. It is indicated in the equivalent circuit. And the source equation is given by V is equal to root 2 sine V sine omega t. Usually we write the equation as V sine omega t, and here this is given with the phase angle omega t plus alpha. Okay. So whenever there is a fault, automatically you consider that the short circuit current consists composed of two phases of current. One is the steady state current and another one is the transient current. So in case of transmission line, due to the short circuit fault, automatically the current will be of steady plus the transient fault, right? With this, I stop my discussion here. If you like this video, like, share, and subscribe. So far, whatever we have discussed is an important part. Those who are preparing for the gate examination, you go through all the videos and have an idea whatever the part which you will get in case of a gate examination preparation. If you like this video, like, share, and subscribe. Thank you.